exploring America's largest abandoned steel mill, industrial giants left to decay. The Bethlehem steel plant in Pennsylvania once employed over 31,000 workers and produced the steel that built the Empire State Building, the Golden Gate Bridge, and the battleships that won World War II. Today, this 1,800-acre industrial complex stands as one of America's most impressive abandoned sites, where massive blast furnaces rise like cathedrals of industry against the Pennsylvania sky, telling the story of American manufacturing power and its eventual decline. Walking through the gates of what locals call the Steel, you're immediately confronted by the sheer scale of industrial ambition. These aren't just buildings, they're monuments to an era when American manufacturing dominated global markets and provided middle-class livings for entire generations of families. The blast furnaces tower 200 feet above the Lehigh River, their concrete and steel construction designed to withstand temperatures exceeding 3,000 degrees Fahrenheit and operate continuously for decades. Bethlehem Steel's story begins in 1857, when the Saucona Iron Company established its first furnace along the Lehigh River. The location was perfect for steel production, close to Pennsylvania coal fields, with river access for transporting raw materials and railroad connections to major markets. By 1899, the company had become Bethlehem Steel Corporation under the leadership of Charles Schwab, who transformed it into America's second-largest steel producer behind only U.S. Steel. The complex grew organically over more than a century, with each expansion reflecting technological advances and market demands. The No. 6 machine shop, completed in 1918, was the largest industrial building in the world at the time, stretching over 1,300 feet long and housing the massive equipment needed to forge naval guns and armor plate. During World War I, Bethlehem Steel produced over 60,000 tons of artillery shells and 70% of the heavy artillery used by Allied forces. World War II transformed the plant into what President Franklin Roosevelt called the arsenal of democracy. Employment peaked at over 31,000 workers, operating around the clock to produce materials for Liberty ships, aircraft carriers, and the infrastructure of global warfare. The company's shipyard launched over 100 vessels during the war, while the steel plant produced armor plating that protected American tanks and battleships across 2 theaters of war. Walking through Blast Furnace C today, you can still see the intricate network of conveyor belts, ore bridges, and charging equipment that transformed raw materials into molten steel. Iron ore arrived by ship from Minnesota's Mesabi Range, coal came by rail from Pennsylvania mines, and limestone was quarried locally. These 3 ingredients were carefully proportioned and fed into the blast furnace, where temperatures reaching 3,000 degrees separated iron from ore and created the molten metal that would be refined into steel. The casting houses where molten iron was poured into molds reveal the dangerous, physically demanding nature of steel production. Workers wearing minimal protective equipment worked in temperatures exceeding 120 degrees, manipulating multi-ton ladles of molten metal with precision, timing, and tremendous skill. The mortality rates in early steel production were staggering. Industrial accidents, heat exhaustion, and long-term health effects from dust and chemical exposure made steelmaking one of America's most dangerous occupations. Labor relations at Bethlehem Steel reflected broader tensions between industrial capitalism and worker rights. The 1910 strike brought national attention to working conditions in heavy industry, while the 1941 strike established union representation that would define labor relations for the next 5 decades. The company town of South Bethlehem provided housing, schools, and social services for workers' families, creating a complete industrial ecosystem where multiple generations worked at the same plant. The decline of American steel production began in the 1970s as foreign competition, environmental regulations, and changing manufacturing patterns challenged traditional heavy industry. Japanese and German steel producers, using newer technology, could produce higher quality steel at lower costs. The Clean Air Act imposed expensive environmental retrofits on aging facilities. The American economy shifted toward service industries that required less raw steel for construction and manufacturing. Plant closures came in waves throughout the 1980s and 1990s. Individual furnaces shut down as orders declined, entire departments closed as automation reduced labor needs, and finally, in 1995, the last blast furnace was permanently extinguished. The company that had employed over 300,000 people at its peak filed for bankruptcy in 2001, ending 144 years of continuous steel production in Bethlehem. The environmental legacy of a century of steel production presents ongoing challenges and opportunities. Soil contamination from decades of industrial operations requires extensive remediation before any redevelopment can occur. The Lehigh River, once heavily polluted by industrial runoff, has been successfully restored to support recreational fishing and boating. Air quality improvements since the plant's closure demonstrate the environmental costs of heavy industry that were largely ignored during the peak production years. Preservation efforts at Bethlehem Steel balance industrial heritage with practical redevelopment needs. The Steel Stacks Arts Campus has transformed part of the site into a cultural destination while preserving key industrial structures as historical monuments. The blast furnaces have been stabilized and incorporated into the new development as dramatic architectural features that honor the site's industrial heritage while serving contemporary cultural purposes. Exploring the abandoned sections reveals the complexity of steel production and the skilled workforce it required. The electric arc furnaces, where scrap steel was recycled into new products, the rolling mills, where steel ingots were shaped into beams and plates, the quality control laboratories, where metallurgists tested chemical composition and structural integrity. Each area required specialized knowledge and years of experience to master. The machine shops contain equipment that represents the pinnacle of 20th century industrial engineering. Lathes capable of machining naval gun barrels, presses that could forge massive crankshafts for ships, and specialty tools designed for specific military contracts. Much of this equipment was custom-built for Bethlehem Steel's unique requirements and represents manufacturing capabilities that no longer exist anywhere in America. Personal artifacts throughout the complex tell individual stories within the larger industrial narrative. Lockers still contain workers' belongings, office walls display family photos and union announcements, and break rooms retain the informal decorations that made industrial work more human. These details remind visitors that steel production wasn't just an economic activity, it was a way of life that shaped entire communities for multiple generations. The view from the top of Blast Furnace B provides perspective on both the scale of industrial operations and the community that surrounded them. You can see the worker housing that lined the streets below the plant, the schools where steelworkers' children were educated, the churches where families worshipped, and the commercial districts that served the industrial community. The entire landscape was organized around steel production, creating an integrated industrial society that extended far beyond the plant gates. Modern steel production has largely moved to newer facilities in different regions or overseas to countries with lower labor costs and fewer environmental restrictions. The skills and knowledge that made Bethlehem Steel a global leader have largely disappeared, as experienced workers retired without passing their expertise to new generations. America still produces steel, but the massive integrated mills that once dominated the landscape have given way to smaller, more specialized operations. The cultural impact of deindustrialization extends beyond economics to questions of identity, purpose, and community resilience. Families who had worked at Bethlehem Steel for 3 or 4 generations suddenly faced unemployment in communities where few alternative careers offered comparable wages or benefits. The social networks built around industrial employment dissolved as people moved away seeking opportunities, leaving behind communities struggling to redefine their purpose and identity. Visiting abandoned industrial sites like Bethlehem Steel provides tangible connections to America's manufacturing heritage and the communities it supported. These places challenge visitors to consider the human costs of economic change, the environmental consequences of industrial production, and the social responsibility that comes with economic power. They also demonstrate the impressive technical achievements and skilled workforce that made American manufacturing a global force. Industrial preservation efforts serve multiple purposes beyond historical education. They provide opportunities for economic redevelopment that honors past achievements while creating new opportunities. They preserve technical knowledge and manufacturing heritage that might otherwise be lost. Most importantly, they maintain physical spaces where communities can remember and honor the people whose labor built modern America. Planning visits to abandoned industrial sites requires understanding both the historical significance and current safety considerations. Many areas contain environmental hazards from decades of industrial operations, structural dangers from aging buildings and equipment, and security restrictions that limit access to certain areas. Professional tours provide safe access while offering expert interpretation of complex industrial processes and historical context. Which aspects of America's industrial heritage do you find most important to preserve and remember? I've included information about industrial heritage sites, steel-making history, resources, and visiting options for preserved industrial complexes in the description below. These places offer profound insights into American manufacturing, worker experiences, and the communities built around heavy industry. Next week, we'll explore the massive railroad complex where steam locomotives were born and died. Week 2, Friday. The abandoned railroad empire that connected America, single script block, 15 to 18 minutes. The sprawling Pennsylvania Railroad complex in Altoona once represented the pinnacle of American transportation engineering, where steam locomotives were born, repaired, and retired in a massive industrial operation that employed over 15,000 workers at its peak. Today, this abandoned railroad empire stretches across 217 acres of deteriorating shops, roundhouses, and repair facilities that tell the epic story of how railroads built America and how America eventually moved beyond them. Standing at the entrance to what locals still call the shops, you're confronting more than just abandoned buildings. You're witnessing the physical remains of the transportation revolution that connected isolated communities, enabled westward expansion, and transformed America from a collection of regional economies into a unified national market. The Pennsylvania Railroad didn't just move people and goods, it moved the entire nation into the modern industrial age. The Altoona Works began operations in 1850 as the Pennsylvania Railroad's primary locomotive repair facility, strategically located at the base of the Allegheny Mountains, where trains required additional power for the challenging climb westward. The location choice reflected sophisticated understanding of railroad logistics. Repairs and maintenance were most efficiently performed at natural stopping points, where trains changed crews, added helper engines, or regrouped for difficult terrain ahead. Walking through the erecting shop today, you can still see the overhead cranes capable of lifting entire locomotive engines, the massive lathes that turned drive wheels weighing several tons, and the forges where railroad blacksmiths shaped custom parts for specific locomotive models. This wasn't mass production in the automotive sense. Each locomotive was essentially hand-built by craftsmen who understood the precise tolerances required for safe operation at high speeds under tremendous loads. The complexity of steam locomotive maintenance reveals the sophisticated engineering knowledge that railroad work required. A typical steam engine contained over 40,000 individual parts, each requiring specific metallurgy, precise manufacturing tolerances, and careful assembly procedures. Boiler tubes had to withstand pressures exceeding 200 pounds per square inch while maintaining water circulation that prevented catastrophic explosions. Drive mechanisms required perfect timing to coordinate multiple cylinders with connecting rods and drive wheels weighing thousands of pounds. Locomotive crews developed intimate relationships with their assigned engines, learning individual quirks and characteristics that affected performance. Engineers could diagnose mechanical problems by subtle changes in sound, vibration, or smoke patterns. Firemen mastered the art of coal firing, maintaining optimal steam pressure through careful attention to fuel quality, airflow, and firing timing. These skills took years to develop and created a professional culture that valued experience, precision, and teamwork above all else. The apprenticeship program at Altoona Works represented one of America's most comprehensive industrial training systems. Young men spent 4 years learning machining, welding, electrical work, and specialized railroad trades, while earning wages and gaining hands-on experience with master craftsmen. The program produced not just skilled workers, but future supervisors, engineers, and managers who understood railroad operations from the ground up. Many graduates spent entire careers with the Pennsylvania Railroad, creating institutional knowledge that made the company exceptionally efficient. World War II transformed Altoona Works into a crucial military asset, producing and maintaining locomotives for both domestic freight service and overseas military railways. The facility operated around the clock, with 3 full shifts, maintaining the rolling stock that moved soldiers, weapons, and supplies to ports for shipment overseas. Women entered the workforce in unprecedented numbers, learning trades traditionally reserved for men and proving their capabilities in challenging industrial environments. The diesel revolution of the 1950s marked the beginning of the end for steam locomotive maintenance facilities. Diesel engines required different skills, different tools, and dramatically less maintenance than steam power. A diesel locomotive could operate for weeks without major attention, while steam engines required daily boiler washouts, frequent mechanical adjustments, and constant attention to coal and water supplies. The efficiency gains were undeniable, but they came at the cost of thousands of jobs and entire communities built around steam railroad operations. Exploring the roundhouse reveals the ingenious engineering that allowed efficient locomotive servicing. The turntable at the center could rotate engines to face any of the radiating repair bays, while overhead cranes moved heavy components between work areas. Steam lines provided power for pneumatic tools, while electrical systems powered the machinery needed for precision work. The design maximized efficiency while minimizing the physical effort required to move multi-ton locomotives and components. The paint shop tells its own story about railroad pride and corporate identity. Pennsylvania Railroad's distinctive Tuscan red paint scheme wasn't just aesthetic choice. It was brand identity that made PRR locomotives instantly recognizable across the transportation network. The precision required for pinstriping and lettering demanded artistic skills alongside industrial techniques. Painters took pride in their work, understanding that locomotive appearance reflected railroad competence and reliability. Tool and die making at Altoona Works represented some of America's most sophisticated manufacturing capabilities. Custom tools for specific locomotive models were designed and built on site, often incorporating innovations that improved maintenance efficiency or safety. The tool crib contained thousands of specialized implements, many hand-forged for particular applications. Master machinists could fabricate replacement parts for locomotives built decades earlier, maintaining operational capabilities long after original manufacturers had ceased production. The decline of Altoona Works paralleled broader changes in American transportation and manufacturing. Trucking captured increasing shares of freight traffic, airlines reduced passenger rail demand, and manufacturing shifted toward lighter industries, requiring less raw material transportation. The interstate highway system, ironically funded partly through railroad taxes, provided competition that railroads couldn't match for flexibility and door-to-door service. Plant closures came gradually through the 1970s and 1980s as railroad consolidation reduced the need for multiple repair facilities. The Pennsylvania Railroad merged with New York Central to form Penn Central, which subsequently declared bankruptcy and was absorbed into Conrail. Each corporate transition brought workforce reductions and facility closures, as new management sought efficiency through consolidation rather than distributed operations. The social impact of Altoona Works closure extended far beyond the immediate workforce. Local businesses lost customers, schools lost enrollment, and municipal governments lost tax revenue. The ripple effects of deindustrialization touched every aspect of community life, from church congregations to youth sports leagues. Entire extended families who had worked railroad trades for multiple generations suddenly faced unemployment in communities with few alternative career opportunities. Environmental remediation at the site reveals the hidden costs of industrial operations that were largely ignored during peak production years. Soil contamination from decades of locomotive fueling and maintenance requires ongoing monitoring and treatment. Groundwater protection measures prevent industrial pollutants from affecting municipal water supplies. The cleanup costs demonstrate how environmental externalities were essentially subsidized by future generations who inherited contaminated sites. Preservation efforts at Altoona Works balance historical education with practical redevelopment challenges. The Railroaders Memorial Museum maintains key buildings and equipment while interpreting the site's historical significance. Some structures have been adapted for light manufacturing and commercial use, while others await resources for stabilization and preservation. The challenge involves maintaining historical integrity while creating economically viable uses for buildings designed for specific industrial purposes. Railroad heritage tourism has emerged as an unexpected economic opportunity for former railroad communities. Visitors from around the world come to see preserved locomotives, experience historic train rides, and learn about transportation history. This heritage tourism generates revenue for local communities while preserving important transportation history and maintaining connections to railroad culture that might otherwise disappear completely. The technical knowledge and skills that made places like Altoona Works function have largely disappeared as experienced workers retired without passing expertise to new generations. Modern railroad maintenance relies more on computerized diagnostics and modular component replacement than the hands-on craftsmanship that characterized steam-era operations. While this represents efficiency improvements, it also means the loss of manufacturing capabilities that took generations to develop. Exploring abandoned railroad facilities provides insights into the scale of infrastructure required to move a continental nation. The Pennsylvania Railroad, at its peak, operated over 10,000 miles of track, maintained thousands of locomotives, employed over 250,000 people, and handled millions of passengers and tons of freight annually. Understanding this scale helps appreciate both the achievements of railroad engineering and the massive economic transitions involved in transportation technology changes. Modern freight railroads operate more efficiently than ever, moving unprecedented tonnages with smaller workforces and lower environmental impact per ton-mile than competing transportation modes. However, passenger rail service in most of America remains limited compared to other developed nations, raising questions about transportation policy choices and infrastructure investment priorities that continue affecting community development and economic opportunities. The legacy of places like Altoona Works extends beyond transportation history to questions about technological change, community resilience, and economic justice. These sites remind us that technological progress creates both opportunities and disruptions, that efficiency gains often come with social costs, and that communities built around specific industries face particular vulnerabilities when economic conditions change. Which aspects of America's railroad heritage do you find most significant for understanding our transportation evolution? I've included resources about railroad history, preservation efforts, and visiting opportunities for historic railroad sites in the description below. These places offer profound insights into American engineering achievements, workforce development, and the communities built around transportation infrastructure. The Fisher Body Plant 21 in Detroit once employed over 40,000 workers producing automobile bodies for General Motors, representing the pinnacle of American automotive manufacturing and the promise of industrial prosperity that defined the Motor City for most of the 20th century. Today, this 3.5 million square foot complex stands as one of America's most haunting industrial ruins, where empty assembly lines and abandoned offices tell the story of American manufacturing decline and urban decay. Entering the main production floor feels like stepping into a cathedral of American industry, where soaring ceilings designed to accommodate overhead cranes stretch into darkness above assembly lines that once produced over 1,000 car bodies daily. The scale of the operation becomes apparent when you realize that this single building could house nearly 80 football fields, all dedicated to the precise coordination of materials, machinery, and human labor that transformed raw steel into finished automobile bodies. Fisher Body Plant 21 opened in 1919 as General Motors expanded production to meet growing demand for affordable automobiles. The Fisher brothers had revolutionized automotive body construction by adapting techniques from carriage making, creating lightweight but strong steel bodies that replaced the heavy wooden frames that characterized early automobiles. Their innovation made possible the mass production techniques that would make automobiles accessible to working-class families for the first time in history. The plant's location in Detroit's West Side reflected the city's emergence as America's automotive capital, where skilled European immigrants, Southern migrants, and innovative entrepreneurs converged to create entirely new industries. The surrounding neighborhoods filled with workers' families who walked to factory jobs that offered wages exceeding anything available in agriculture or traditional manufacturing. This was the foundation of Detroit's transformation from frontier lumber town to global industrial powerhouse. Walking through the stamping department today, you can still see the massive presses that shaped flat steel sheets into fenders, doors, hoods, and roof panels. These machines, some weighing over 500 tons, could exert pressures exceeding 1,000 tons per square inch while maintaining tolerances measured in thousandths of inches. The precision required for automotive bodywork demanded both sophisticated machinery and skilled operators who understood how steel behaved under extreme pressure and heat. The assembly line concept revolutionized manufacturing by breaking complex production into simple, repetitive tasks that could be performed by workers with minimal training. Henry Ford's innovation at nearby Highland Park inspired similar approaches throughout American industry. But the human cost of assembly line work became apparent as workers experienced unprecedented levels of repetitive stress, industrial accidents, and psychological strain from monotonous labor performed at machine-dictated speeds. Labor organizing at Fisher body plants played crucial roles in establishing industrial unionism and workers' rights that defined American labor relations for decades. The famous Flint sit-down strike of 1936 to 1937 began at Fisher body plants and established the United Auto Workers as a major force in American labor relations. Workers occupied plants for 44 days, facing company security forces and National Guard troops while demanding recognition of their right to collective bargaining. The diversity of Fisher Body's workforce reflected broader demographic changes in American manufacturing. The Great Migration brought African American workers from the rural South seeking industrial opportunities, while European immigrants contributed technical skills and strong labor organizing traditions. Women entered automotive production during both world wars, proving their capabilities in roles traditionally reserved for men and challenging assumptions about industrial work and gender capabilities. World War II transformed Fisher Body Plant 21 into a crucial military production facility, manufacturing aircraft components, tank parts, and military vehicles instead of civilian automobile bodies. The conversion required extensive retooling and workforce retraining, but demonstrated American industry's remarkable ability to adapt quickly to changing requirements. The plant operated around the clock throughout the war, with workers understanding that their production directly supported combat operations overseas. Post-war prosperity brought unprecedented expansion, as pent-up consumer demand and suburban development created massive markets for new automobiles. Fisher Body Plant 21 expanded operations and employment, producing bodies for multiple General Motors divisions, including Chevrolet, Pontiac, Oldsmobile, Buick, and Cadillac. The plant became a symbol of American industrial might and the foundation of middle-class prosperity for thousands of families. The 1970s brought multiple challenges that would eventually doom plants like Fisher Body 21. Foreign competition from Japanese and German automakers offered higher quality vehicles at competitive prices, exposing weaknesses in American automotive design and manufacturing. Environmental regulations required expensive modifications to production processes, while energy crises changed consumer preferences towards smaller, more fuel-efficient vehicles that American manufacturers were slow to provide. Automation began replacing human workers throughout the 1980s as General Motors invested heavily in robotic welding, painting, and assembly systems. While automation improved quality and reduced long-term labor costs, it also eliminated thousands of jobs and reduced the skilled workforce that had been the foundation of automotive manufacturing communities. The transition proved particularly difficult for older workers whose skills became obsolete and younger workers who found fewer entry-level opportunities. Plant closures accelerated during the 1990s as General Motors consolidated operations and moved production to newer facilities in lower-cost regions. Fisher Body Plant 21 closed permanently in 1993, ending 74 years of continuous automotive production and eliminating over 3,000 remaining jobs. The closure symbolized broader deindustrialization trends that transformed Detroit from thriving industrial city to symbol of urban decline and economic abandonment. Exploring the administrative offices reveals the complex management structure required to coordinate automotive production. Engineering departments designed body components and production processes. Quality control offices monitored manufacturing standards. Personnel departments managed workforce issues, and accounting offices tracked costs and productivity metrics. The integration of these functions required sophisticated organizational systems that represented major advances in industrial management. The paint department showcases the chemical complexity of automotive finishing, where multiple coats of primer, color, and clear coat were applied under carefully controlled temperature and humidity conditions. Environmental regulations eventually required expensive modifications to painting processes, as older facilities struggled to meet air quality standards without prohibitive capital investments. Many plant closures were triggered by environmental compliance costs that older facilities couldn't economically justify. Tool and die shops within the plant manufactured the specialized equipment required for automotive body production. Master craftsmen created the dies, jigs, and fixtures that shaped steel into precise automotive components, often working from hand-drawn blueprints to create tooling that would be used for years of production. This represented some of America's most sophisticated manufacturing capabilities, combining traditional metalworking skills with cutting-edge industrial technology. The cafeteria and recreational facilities remind visitors that automotive plants were complete industrial communities where workers spent significant portions of their lives. Company-sponsored sports leagues, social events, and training programs created networks that extended far beyond work relationships. These social connections helped sustain communities through economic difficulties and provided mutual support systems that characterized industrial working-class culture. Personal artifacts throughout the abandoned plant tell individual stories within the larger industrial narrative. Lockers still contain workers' belongings, bulletin boards display union announcements and family photos, and break areas retain informal decorations that made industrial work more human. These details remind visitors that automotive production wasn't just economic activity. It was a way of life that shaped entire communities and multiple generations of families. Drop a like and comment below. Be sure to subscribe to next week's content, where we'll explore more hospitals, railroads, and automotive plants.